MEC. What is MEC? Well, multi-access edge computing. Andy, you just gave a great overview of that at the MEC Congress here as part of the Carrier Network Virtualization Conference. Why don't you tell us a little bit about what that is, and we'll have a conversation.
Well, MEC stands for, as you say, multi-access edge computing. Now, what that essentially means is creating an IT ecosystem for applications at the edge of the network. The multi-access part means it could be any way of actually accessing it. So it could be 4G, it could be 3G, it could be Wi-Fi, it could be fixed line. But however you access this local IT cloud, it's basically an edge cloud, it doesn't really matter, it's multi-access. But the benefits of having that edge compute resource is that third-party application developers can bring any of their innovative services to run there. It creates a whole new ecosystem of value chains, of the developers selling to local IT managers, maybe to local telco operators, and it generates new streams of revenue, which you wouldn't necessarily get by simply always long-lining into the central cloud, because creating a little community, whether a village or an enterprise or a shopping mall, they have specific reasons for services there in that place, and that place is the best place to serve those services as opposed to cloud-based. It's a very important movement that we've actually gone on to now to create that new ecosystem, so we're very pleased.
In this, you were speaking on behalf of ETSI. The MEC is a part of an ETSI process. Why don't you explain that process?
That's right. ETSI MEC as a standards group was created 2 years ago in 2014, and at the time it was called Mobile Edge Computing, MEC. But over the last 2 years, there's been many APIs developed and many specifications. The ETSI MEC group has created a reference framework and a reference architecture, and has started pulling in application developers. And there's a lot of good work over the last 2 years. But the interesting thing is they've realised after those 2 years that they shouldn't really focus on mobile cellular, and hence they have actually changed their name now for the next 2 years of their remit to be multi-access edge computing.
It sounds like you're harmonizing, I think that was your exact words, harmonizing with NFV, so that those two efforts are complementary.
One of the big drivers is actually to bring together the IT community with the telco and specifically the cellular world, and Wi-Fi as well. Historically, they've always had different tracks, technology, user groups, things like that. So one of the great things about bringing things into the multi-access edge computing umbrella is that hopefully we can leverage everybody's expertise to generate that new app ecosystem. IT developers are very, very innovative, they can bring that kind of thing. The operators, well, yes, they have the cellular spectrum. The Wi-Fi community is great for enterprises and consumers. We want them all to work together to create this multi-access edge computing environment.
And you're looking at standard APIs like REST type APIs and so forth?
That's right. The ETSI MEC has specified quite a common, to be honest, IT framework for their APIs, and that's RESTful APIs, yes.
I know in the afternoon here you're going to be talking about applications and what this means for the future. So why don't you talk a little bit, give us a summary and an overview of what you're going to be talking about.
Well, MEC is a stepping stone to 5G. Now, we don't necessarily know fully what 5G means in its full environment, but this afternoon I'll be touching on two very specific technologies. They do crop up in 5G, and I'll explain how they move or how they apply to MEC. The first technology is software-defined networking, or SDN. Now, that is all part of the 5G movement to do with disaggregation of the core. It's a long word, but essentially they're breaking apart all the parts of a traditional cellular network to make it more aligned with IT principles. The other aspect I'll talk about later is to do with network slicing. Now, what network slicing means is an end-to-end quality of service guarantee all the way through the network to, from your handset or actually an IoT device to the end goal, the end service. And the principle of that is to have, it could be a wide slice, it could be a narrow slice, but they're all very, very carefully defined. And MEC is perfect for that, for creating local slices. And actually this afternoon I'll be talking about all that in the context of a healthcare environment. So I'll be talking about how different groups of people in the hospital can have different profiles and to do with the different state of the hospital, normal, critical emergency mode, that kind of thing, and how all these things change and to do with network slicing in that environment.
So a doctor might have one access or one kind of slice versus, say, a physical therapist or something?
Well, certainly the doctors is one of the groups, yes. Another one would be the public, visitors. And another group of users would be IoT, and this would be the actual medical equipment, which are IoT devices being pushed around. They could all have different quality of services on their network slice. But imagine, for example, if a hospital went from a normal state into a major incident state. Something's happened. Right, so you can now dynamically change the value of all those slices. For example, the public could get a much diminished slice, and the radio is re-architected the slices to get better quality for the doctors or even the medical IoT equipment. And so all that can be done dynamically, and it's all done locally. You don't need the operator to try and do all that. It's all controlled by, well, ultimately the hospital manager to define what kind of services and quality all these groups of people can get.
And again, back to those RESTful interfaces, it might be a machine-to-machine interface doing that automation, right?
Well, that's right, and there's so many app developers in the healthcare environment. It's a critical infrastructure, hospitals, so the applications are quite critical in how they operate. But that ecosystem can write applications to drive local, whether it's tracking a trolley or an IoT on a actual heart machine or something. All that community can be managed locally. You don't need the operator. That's the biggest part of it all. The hospital and the doctors and the healthcare environment can keep control of their own machines in their own environment. That gives them security, that gives them robustness, and to a large extent independence from the outside network.
And I imagine it also reduces latency because you're not going out.
Reduced latency is one of the big pillars of 5G, so you're absolutely correct. The high bandwidth locally and the low latency, because the packet is not going very far, it's being kept locally. They are one of the several pillars of 5G. We don't need to wait for 5G for a MEC, but you're right, we can do all that now, whether it's 4G or Wi-Fi, yes.
Excellent. Well, Andy, I appreciate your insight. Thank you.
All right, thank you very much.